Today we'll do some MCQs from the chapter real numbers and take the first question. The greatest number of 5 digits exactly divisible by 15, 24 and 36 is. So first step is we need to find out the lowest number which is divisible by 15, 24 and 36. That means we are going to find out the LCM of these three numbers. So for that we can go for prime factorization method. So let's take the LCM. LCM of 15, 24 and 36, and if you take 3, it will be, you can go for 2, so that you will get 4 and 6. Again by 2 you will get 2 and 3. Now 3, just multiply all these terms, 10, 30, 60, 120, 360. So the LCM of these three numbers is 360. So now we can say that 360 and all its multiples are divisible by 15, 24 and 36. So now the question is, which multiple is to be considered? So, and you know what is the largest 5-digit number? We can say largest 5-digit number is 99,999. So what we should do, we are going to divide this 5-digit number by 360. So 99,999 divided by 360. So we can see that it goes into 720, 972, bring down the 9 again. And 360 into 6 will give you 18, and if you go for 7 it will be 25, right? So we can go for 7. So 2520, subtract 7, 2 and bring down. Again 7 will go 2520 and the remainder will be 279. And what is the quotient? Quotient is 277. Now what? So what we are going to do is take this number, that is the 5-digit number, and then from that 5-digit number we will subtract the remainder. So 99,999 minus 279, and that will give you 99,720. And you know 99,720 will be the 277th multiple of 360. So the answer will be 2. So when you get question like this, what you should do is take the LCM and take the 5-digit number, divide it and take the remainder and subtract from the given digit. Similarly, you can adopt the same method for greatest number of 4 digits or 6 digits, whatever it is. Okay, you adopt the same method. So the next question. For positive integers a and 3, there exist unique integers q and r such that a equal to 3q plus r, where r must satisfy, and the options are given. So for solving this question, we know what is Euclid's division lemma. According to Euclid's division lemma, for positive integers a and b, there exist unique integer q and r such that a equal to bq plus r, and also the condition is 0 less than or equal to r less than b. And look at this case here in this question, in place of b you have 3, so definitely our answer will be 0 less than or equal to r less than 3, and all that is option A. Option A. Okay. If HCF of 16y is equal to 8 and LCM of 16 and y equal to 48, then the value of y is. So to solve this question, you should know HCF of two numbers a and b into LCM of two numbers is equal to product of two numbers. This is the formula we are going to apply. So here in this question, in place of A we have 16 and in place of B we have Y. That's it. So HCF is given. HCF is 8. So 8 into LCM is 48 and that is equal to product of two numbers. Which are the two numbers? 16 and Y. 16 into Y. So how will you find out Y? Y will be equal to 8 into 48 divided by 16. So cancel this. You will get 8 into 3. So Y equal to 24. So we can take the option 1. So next question is, if two positive integers A and B are written as A equal to x cube y square, B equal to xy cube, x and y are prime numbers, then what is the HCF of AB? So you don't have to write the steps and all. From here, it's from the question itself we can find out. Look at this x cube and x. For finding the HCF of two numbers, what we do is we will take the exponent with the lowest power. So in this case, we can take x only because the power of x is 1. So we are taking the lowest power into. Now here you have y square and y cube. And out of y square and y cube, you know that the power is less for y square. So xy square. So in one step, you will get the answer. And that is xy square, option B. The decimal form of 129 by 2 square into 5 raised to 7 into 7 raised to 5 is terminating, non-terminating, non-terminating, non-repeating, and none of the above. So for this, you should think about the theorem 1.6 and theorem 1.7 in the chapter real numbers. So there we studied that if the denominator is of the form 2 raised to n into 5 raised to m, then we can come to the conclusion that it is terminating. The decimal expansion is terminating. And if it is not of the form 2 raised to n into 5 raised to m, then it is non-terminating and non-repeating. Here you can see in the denominator you have 7 raised to 5. And if it is terminating, it should be 2 raised to n into 5 raised to m. And for non-terminating, there can be other numbers also. So we can come to the conclusion that it is option C. Now, the largest number that will divide 398, 436 and 542, leaving remainder 7, 11 and 15 respectively. So you should find out the largest number that will divide all these three numbers. But the remainders are given over here, 7, 11 and 15. So the first step is to take 398, subtract 7 from it. So you will get 391. 436 minus 11. So you will get 425. And 542 minus 15. And that will give you 527. Now pick out the greatest number and the smallest number out of this. Which is the greatest number? Greatest number is 527. And the smallest number is equal to 391. Now we are going to go for long division method. 527 divided by 391. So it will go one time. So 391 subtract, you will get 136. Again, you can divide 391 by 136. So it will go two times. So it will be 272. Subtract and you will get 119. Again, you divide 136 by 119. It will go one time. 119, and when you subtract, the remainder will be 17. Again, you divide 119 by 17. So it will go 7 times. So the remainder will be 0. So this is our HCF. Now there is one more number, that is 425, and we should check whether 425 is divisible by 17. So 17 how many times will go? 17 into 2, 34 and 85. So it will be 5. So 425 is also divisible by 17. So we understand that the HCF is equal to 17. So option A. Option A.